zipper, 25 to 29, the 29 to 33, the 33 to 37, and of course, there is a double glycine zipper, if you want to look at it, 25 to 33, and of course 29 to 37. And let's not forget the triple 25 to 37. So we've got a myriad of possibilities that we could investigate, and let's see what in fact came about. We also looked at pseudopeptides to see what is the sequence of each of those glycine zippers. Is it significant? And we chose a reverse sequence, 21 to 17. You can look at the 21 to 17, a reverse process. We also looked at 17 to 21, where we've converted the two phenylalanines into polar glutamic acid residues. Now, I appreciate that even in this one, even in this reverse sequence, one of the phenylalanines remains in the same position. So we are aware of that. We took cognizance of that. But we also replaced the phenylalanines with a glutamic acid. We also took the 33 to 29 and reversed that process, 33 to 29, and in fact replaced the isoleucines with glutamic acid. Now, I know some of you might jump down and say, well, why did we select those particular glycine zippers, motifs? Obviously, with a lot of homework, a lot of gnashing of teeth, a lot of frustrations, I'm just cutting down and giving you the details of what we really looked at. So we were investigating these particular pseudopeptides plus the other ones in our reaction with nitric oxide synthase and, of course, the other enzymes. Now we see the details. There is a time zero. So what we've done is taken the enzyme, nitric oxide synthase, and incubated it with each of these peptides. No pseudopeptides in this case. And within minutes, depending on the peptide, we found the enzyme was inhibited, nearly 100%. And when the student came to me with the results, I said, no, go and do it again. It doesn't make sense. And the student did it again and found the same effect. But what was interesting is when the student went off to lunch or tea or whatever it was and came back, within, I think it was about an hour, I can't remember the details of time, the enzyme activity was restored. The nitric oxide enzyme activity was restored in the same vial. Now, this pointed to us that the enzyme itself was converting the peptide, after being inhibited, the peptide was converted into something different, some other format. And that's where we led the idea that it was converted to a soluble fibril, and eventually, as I'll mention, an insoluble fibril. So this is the effect with the pseudopeptides, and I put in the 17 to 21 and 29 to 33 as kind of a control situation. And you can appreciate the green one and the purple and the blue and the orange. They are the other peptides, and you can see the effect is not as pronounced. So that pointed us that the two phenyl amino acids in the 17 to 21 and the two isoleucine residues in the 29 to 33 were critical to the mechanism of inhibition. The hydrophobic amino acids, phenylalanine and isoleucine, in those two or those four positions were critical for the mechanism of this kind of inhibition. This is a table which illustrates that the peptides, if you have time to digest the numbering, and the Ki or the IC50, I'll try to draw an equivalent, and we'll see 8.5, 9.2, but the interesting one, if we come down to the lower level, we're 17, where we've now replaced the hydrophobic amino acids with glutamic acid. We see we go out to about 19, and here we've gone from the isoleucine ones. There we have the glutamic acid on the 29 to 33, replacing the isoleucines, and we're out at 21. Most interesting is this one here of 29 to 33, which has the lowest Ki value of 3.2. Maybe not stunning, not sort of rocket chemistry where we have nanomolar details, but still an interesting challenge that we have uncovered something in an in vitro analysis. Then we went ahead and looked at soluble fibrils. Now, if you can remember